Alexa, turn on beam.
Okay.
As you might have seen in the previous clip, I like things that are controlled by voice. And to use voice, I need to use Alexa. And to use Alexa, I need Wi-Fi. Now the LED strip you saw earlier came with one of these. It's an infrared receiver and also one of these, a little remote, but no Wi-Fi. So I had to build something myself, and I used for that a WIMOS D1 Mini and 3 MOSFETs, and came up with this, a little black box that does everything I need. If you want to see what's inside, stick around. So let's open it up. First, a quick look on the outside. There's a power connector. This takes 12 volts. And there are 4 leads. One is a 12 volt lead and the other 3 are red, green and blue, and I can't remember which order. It's a bit greasy and dusty. It's been about 2 years since I've opened this up, so I have no idea how it looks on the inside. This, by the way, is just a simple cheap project box. I use them for everything. Probably used this for something else and decided not to use that anymore. There's some drawing on there. Well, that's a bit of a mess. Let's see if I can take this out without destroying it. It's wrapped in some heat shrink, and I used some tape to hold it all together. But this is basically it. It's a 12 volt in. There are 3 MOSFETs, which are 3 of these. Let's see if we can focus that. It is an IRFZ 44N. There are 3 of those. There's the WIMOS D Mini, and this steps down the voltage to, I think it's 5 volts. Yes, it's 5 volts for the WIMOS. As I said, it uses 3 of these power MOSFETs, and just a quick explanation on how these work. This is the MOSFET. The pins are gate, drain and source, and the symbol is something like this, which is gate over there, the drain over there and the source over there. The basic idea of a MOSFET is when applying a voltage on the gate, positive voltage, it allows a current to flow between drain and source, and the drain and source can be any voltage. Well, not any voltage. The MOSFET has to be rated for a certain voltage, but in this case it's the 12 volts that go to the LED strip, and this is perfectly fine, this one for 12 volts. Now, how does this all fit together and make up this? Well, it's not that difficult if you know what you're doing, of course. We start off with this one, the WIMOS D1 Mini. Let's grab a pen. I'll draw it like this. There's a 5 volt pin we need. There's a ground pin we need. And there are a few PWM pins we need. There are more on there. I'll just draw one for now. Then there's this guy. This is a DSN 5000 step down converter, which takes 12 volts and steps it down to 5 volts and 0 volts. Well, the 0 volts, easy, connected to ground, and ground is also connected to ground. 5 volt is connected to 5 volt over there. Now the 12 volt goes to one of the LED arrays in the LED strip. I'm just gonna draw one like this. Those are not really nice LEDs, but it will work. Another one, and there's also a current limiting resistor, and that is connected to 12 volts. Now the PWM pin is connected to the gate of the power MOSFET. The source, the drain is connected to the LED strip, and the source is connected to ground. That's basically it. Let's build this on a breadboard. So before I do anything, I have to set the step-down converter to spit out 5 volts to go to the D1 Mini. So let's grab a little screw driver, connect the 12 volts, and to make my life not more difficult than it already is, no, just kidding, I have a perfect life, or perfect. Well, I'm using yellow for 12 volts and red for 5 volts, and so I don't mix those two up. So let's connect the power and see where it's at. It's at 9.5, so I have to go down. I can never remember which way around is up or down, but that will be easily to see. There we go, it's going down. Let's go down until we reach 5 volts. .3, and there we are, 4.99. I have a bit of an OCD, so it has to be 5 volts. There we go, 5 volts, done. Now I've connected another 12 volt line to the plug that goes to the power adapter because I need 12 volt for the LEDs and 12 volt for the step-down converter. The 12 volt to the LEDs goes to the anode of a few LEDs in series, and there's a current limiting resistor. I was almost going to use the red one. I said I was going to use something else. Let's use white. We need the MOSFET as well. Just put it in here somewhere. Over there, bend it a bit so it looks a bit nicer. Again, it goes gate, drain, source. So the cathode of the LEDs in series goes to the drain. Ground will connect anywhere. We'll connect it into a ground rail over there. The 5 volt we need to go to the MOSFET, the D1 Mini. So let's grab the D1 Mini and put it in the breadboard. Let's see, there we go. Will that fit? It's not the best breadboard I have. Takes a little bit of convincing. Doesn't want to go in. Let's try it again. There we go. So the 5 volts from the step down converter goes to the 5 volt pin, which is this one. The ground pin is again connected to ground. Let me grab another black wire. There we go. So ground is next to the 5 volt, goes to ground. And there's another ground we need for the source of the MOSFET. Blue is close enough to black. That also goes to the ground rail, and in this case we connect it to the source of the MOSFET, which is a bit difficult to see, this pin. And then we have the PWM pin, which I'm going to use orange, just because the Dutch female soccer team is playing in the finals today, so that's why I'm using orange. And I'm going to use pin D1, which is, let me see, it's difficult to see on camera, which is a PWM pin on the WiMOS D Mini, and that goes to the gate. Now, before I connect anything, especially the power supply, to the D1, I need to load some code onto this, because if I'm going to connect it now, I have no idea what's on this, and it might all just go horribly wrong. So let's write a bit of code.